Evaluation is in all sciences, in all technologies, an important topic. In machine learning and in artificial intelligence, this is also the case. With software, evaluation is crucial. Software needs to be used safely in many, many cases. There are two big ways to evaluate software. One of them is through mathematics. You try to prove the software. The second way is through testing, and software engineers spend a lot of time testing what they have produced. In the case of artificial intelligence and machine learning, this is also extremely important. But there is a difference. Whereas in a piece of software you are expecting a correct answer all the time, in the case of machine learning, we are not always expecting a correct answer. We're just expecting the system to make a number of errors which is acceptable. So therefore, what we're really trying to do is obtain a guarantee on the quantity of errors, on the quantity of mistakes the system will make. Let's take one example. Let's suppose we have bought or have got a piece of software which is machine learning powered and who is supposed to help us to grade some papers done by pupils. Well, why would this piece of software make mistakes? There are a number of reasons. The first one is that perhaps it's not been properly trained. We know that machine learning relies on examples, and of course, if the system has been given too few examples, the number of errors it will make will not be as good as if it has been trained on many more. The second reason is that perhaps the examples that we have been using for training don't look at those corresponding to our own pupils. And this is the case if they come from two different countries, for example. So perhaps we can't really use software which has been trained somewhere else. And the third one is perhaps also that we are using the software which comes with some guarantees, but which doesn't correspond to the actual application we want it for in the classroom. We'll have to think about that also. So when we talk about errors, we often see them as magic numbers, 3%, 2%, 5%, but we would like them to mean something. What can they mean? Typically, an error of 3% in a classification system will mean that in 100 cases, 3 of those will be errors. I may have a fail instead of a pass, or a pass instead of a fail. Or I can have a system which is helping me to grade, and I will have an error measuring how far away will the system be when predicting a grade with the grade I would have given it itself. So these systems that give errors, we have to make sure we interpret correctly. Let's just have an extreme example. Suppose I want to predict if a child is going to be a doctor or not. Then a system that will always inevitably predict no will actually be very good under the criterion of the magic numbers, because it is supposed that in the population of a Western country, there are in average 1.5 doctors per 1,000 inhabitants, which really means that there is less, much less than 1% error for a system that predicts that nobody will ever become a doctor. This, of course, is addressed by people working in machine learning, but it is not always easy to read. So how would we want to evaluate an error? In the old days, you would just wait and see. So you have to understand that prediction has always existed, and in the Middle Ages, people who were predicting the future were called witches, and they were often burnt. So we don't want that to happen today, so we don't do it that way, and people want a guarantee before things happen. Therefore, we have to have an experimental setup allowing us to predict not just the result, but predict how many errors we are going to be making in the future when we use the system that has been developed. There are a number of theoretical and practical protocols that are used by scientists who do artificial intelligence. And some of these are actually very close to those that the doctors are going to use when they want to introduce a new drug. You have two populations, and one of the population is using the old drug and the other population is using the new drug, and none knows which ones they are using, and you will just measure success after a few months of treatment. So we do the same, and it is called A/B testing. But we should always remember that when we are doing testing, we're only getting an estimation of the error. We don't have any certainty of what is going to happen in between things, because the populations will be changing over time. And this is, of course, extremely the case in the case of education. An important question when you do testing is to look out for bias. So what is bias? So bias will be the term employed when we use a model which is going to create either a positive inclination or a negative prejudice against either one individual or a group of individuals. And usually we will consider this to be unfair. Probably the group for whom the inclination is meant will not find it unfair, but other people will find it unfair. So bias can appear in a number of ways. The process of data collection can be to blame, and therefore when we have collected, we have only been collecting data with one particular subgroup. But also there is just bias in society, and therefore the data we will be collecting, however fairly, will contain the bias that is in society. So what's going to happen with the learning algorithm? The learning algorithm is trying to achieve success. Its goal is to try and obtain results which are even better than the human expert. And sometimes to obtain success, sadly, the best answer is to be biased. So in different ways, we have to check and test for this bias. There has been a lot of work done over the past few years on the subject of bias in AI. Let me publicize just one paper that can be found on the web, where the UNESCO actually went through all the different forms of bias related typically to gender, but not only. And this report was produced in 2018 and gives us an understanding of how bias, when present in the data, then can also be present in the software. Statistics only tell us part of the story. So, with this final slide, what we want to explain or discuss is that as a teacher, as an educator, when we use these systems, which can be brilliant systems, we should not be mesmerized by these percentages. These percentages really mean that they have been thoroughly tested. But we are not aiming to take the system that makes 5%, because perhaps it is not the one that suits the educational purpose we really want to get to. So that's the first point. The second point I want to make here is that there is always a risk when you predict the future that you actually then try to make sure that this prediction becomes true. For example, if we've got a system which is telling us what are the grades that our children, our pupils are going to achieve in 6 months' time, we want to be careful that as educators, we don't then feel somehow obliged to actually follow the prediction and grade the students in the way the system has told us it should work.